What if I told you that the universe as you know it might never have existed at all? You are sitting here right now, looking at a screen, reading words that feel familiar. Everything seems clear and solid. The table in front of you, the room around you, the sounds drifting in from outside. From the moment we are born, we never really question any of it. The world is treated as something already there, standing still, waiting for us to step in and observe. We grow up with this simple belief, that there is a physical world out there, independent of whether we are looking at it or not. Even if we close our eyes, walk away, or disappear entirely, everything keeps going. That belief is so strong that no one feels the need to prove it. It is like the ground beneath our feet, so solid that we forget it is even there. And yet, inside quiet laboratories, some scientists began to feel uneasy. The numbers, the measurements, the data kept pointing to something strange. They suggested that the universe does not behave the way we have always assumed. Some phenomena appear only when they are observed, then vanish the moment no one is looking. Some things seem not to exist at all until the instant we check on them. The question that followed was not loud or dramatic, but it was powerful enough to keep people awake at night. Does the universe truly exist on its own, or does it only take shape when someone is watching? This is not imagination or vague speculation. It comes from serious experiments, repeated again and again, all producing the same unsettling results. Once that question is asked, everything familiar starts to feel fragile. What we trust most is no longer the outside world, but the way we experience it. To understand why this idea is so disturbing, we have to return to the very beginning, to human perception itself, the one thing we have always trusted without ever questioning. If you want to continue this journey, to go deeper into the experiments that left scientists confused, and the results that forced us to rethink what reality even means, stay with me. Watch until the end, and if you do not want to miss stories that shake the way we see the world, do not forget to subscribe. Because sometimes, the most frightening thing is not that the universe is too strange, but that it may be far closer than we ever imagined. From the very beginning, humans have believed that what the eyes see is the world itself. Whatever the ears hear must be real and present around us. The warmth or chill we feel on our skin seems like clear proof that we are in direct contact with reality. This belief feels simple, natural, almost impossible to question. And yet, when we take a closer look at how the brain actually works, a quiet truth begins to surface. The brain is not a mirror that reflects the world exactly as it is. It is more like a storyteller, constantly selecting, organizing, and editing information before it reaches our awareness. Its goal is not to reveal absolute truth, but to keep us alive. The brain only needs to construct a picture that is stable enough, familiar enough, and easy enough to understand so we can respond quickly to our surroundings. When sunlight reaches the earth, what truly exists are invisible waves traveling through space. They have no red, blue, or yellow. But when those waves enter the human eye, the brain gets to work. It sorts them, compares them, and assigns each group a familiar label we call color. The blue of the sky, the red of a flower, the golden glow of an evening sun, all of these appear inside the mind, not out in the world. Sound works the same way. Out there is no birdsong, no rustling wind, no passing traffic. There are only vibrations moving through the air. When those vibrations reach the ear, the brain turns them into meaningful sounds. What we hear is not the world itself, but the brain's translation of the world. That translation is incredibly useful and vividly alive, but it is not the original truth. Even pain and pleasure do not exist independently outside us. They are warning signals created by the brain to protect the body. When something sharp touches the skin, the brain interprets the signal as pain, causing us to pull away. That sensation has a clear purpose, helping us avoid danger. It was never meant to accurately describe the true nature of the sharp object. When we put all of this together, something strange begins to emerge. What we call the familiar world is actually a picture constructed inside the mind. This picture is painted with colors, sounds, sensations, and emotions. It feels seamless, logical, and consistent, good enough for us to move through daily life without trouble. But that very smoothness makes us forget that it is only a model. This model works so well that humans rarely notice it exists at all. We wake up, go to school, go to work, talk, think, and fall asleep, all within the same familiar picture. Everything fits together too perfectly. And that perfection convinces us that we are touching reality directly, with no filter in between. In truth, the brain always stands between us and the world. It is a silent gatekeeper, deciding what is allowed into consciousness. Details that do not matter for survival are discarded. What matters is emphasized. We never see the whole world, only the portion the brain decides is enough. This is not a flaw. The brain is doing exactly what it evolved to do. Over millions of years, creatures with simple, efficient, predictable models of reality survived better. The human brain is the result of that process. It was not designed to uncover the deepest truths of the universe, but to help us avoid danger, find food, and build social bonds. Once we reach this understanding, a slow and unsettling question begins to form. Are the experiences we have every day the real world, or just a survival picture painted by the brain? Are we living in reality itself, or inside a highly convincing model of it? This question is uncomfortable. It feels like discovering that the window you have been looking through your whole life is actually a screen. The view is still beautiful, the light still familiar, but the sense of trust has shifted. You begin to realize that you have never touched the world directly, only the brain's interpretation of it. As this idea spreads, everything around you starts to feel more fragile. A table is no longer just a table, it is a collection of signals given meaning by the brain. A room is not just physical space, it is a sensation of space constructed by the mind. Even the body itself is experienced through this layer of interpretation. And yet, here is the most striking part. Even if it is only a model, there is no escape from it. Humans have no choice but to live inside the picture created by their own brains. We cannot step outside our perception to check what the original world truly looks like. Every observation, every thought, every doubt happens within that model. Because of this, the question is no longer whether the model is right or wrong. The question becomes what the model is hiding. Behind familiar colors and sounds, there may be a structure completely different from anything human intuition can grasp. Perhaps true reality has no shape, no color, no sound at all, at least not in the way we imagine. From here, a bold idea begins to take shape. What if everything we see is only the surface, like icons on a smartphone screen? You tap an icon and an app opens, but the real substance lies deeper, in lines of code the eye can never see. Once perception is understood as a survival model, absolute trust in what we see begins to crack. We are no longer certain that the world appears as it truly is. Familiarity no longer guarantees truth. From this point on, humanity is forced to confront a powerful hypothesis, the idea that the entire world we know is only an interface, not the underlying reality. And it is this very hypothesis that opens the door to a radically new way of looking at the universe, a universe where everything we see is just the surface of a deeper structure, quietly shaping everything beneath it. As the idea that perception might be nothing more than a survival model becomes clearer, a scientist named Donald Hoffman proposes an even more radical view. He does not argue that humans misunderstand parts of the world. He suggests that we may have never seen reality as it truly is. According to Hoffman, evolution does not care about truth. The only thing it favors is survival. In nature, creatures that react faster to danger are more likely to live. Those that conserve energy tend to last longer. For that reason, the brain does not need to know things as they really are. It only needs a simple, easy-to-use picture that allows it to make the right decisions at the right time. Truth, in many cases, is too complex and too slow to be useful for survival. Hoffman offers a familiar example. When we use a computer, we see colorful icons. A trash can icon, a folder icon, a pencil icon. We click on them and everything works smoothly. Yet beneath those friendly images are millions of lines of complex code. The user does not need to know what that code looks like. Knowing too much would only make things more confusing. Reality itself, Hoffman argues, may work the same way. What we see, tables, trees, people, the sky, space, time, may all be icons. They help us live, work, and communicate. They are not meant to reveal the deep nature of the universe. They hide that nature so we are not overwhelmed. When you look at a table, you think you are seeing a solid object sitting still in space. Under the interface theory, what you see is only a symbol that allows you to interact. The true nature behind the table could be completely different, with no familiar shape, unlike anything you have ever experienced. The brain simplifies it into a stable object so you can place things on it, lean on it, and use it. Space itself may also be part of the interface. We are used to measuring distance in meters and moving from one place to another. The brain needs a clear spatial framework to guide the body. But the space we experience may not be the foundation of the universe. It may simply be how the brain organizes experience so we do not lose our way. Time may be the same. We feel it flowing from past to present to future. That feeling helps us remember, predict, and plan. It is essential for daily life. But that does not mean time exists exactly as we perceive it. It may be nothing more than a ruler the brain creates to arrange events in an understandable order. This hypothesis makes many people uncomfortable. It challenges the deep belief that we live in a direct, unmediated reality. It suggests that the most familiar things may be only a surface layer. Still, Hoffman does not make this claim casually. He bases it on research into evolution, perception, and how organisms respond to their environments. In computer simulations of evolution, creatures programmed to see the truth often lose to creatures that see only simple but useful signals. Knowing too much slows reaction time. Knowing just enough leads to survival. These results suggest that human perception may have traded truth for efficiency. At this point, the question grows heavier. We may not just misunderstand the world, we may have never truly encountered it. We are like computer users who believe the icons are the entire system. That belief works fine in everyday life, but it collapses when we try to understand what lies beneath. The interface theory does not claim the world is fake. It claims that what we see is not the real world. Reality still exists, but it is hidden behind a friendly interface designed for humans. That interface is good enough for living, loving, learning, and building societies. It is not good enough for understanding what the universe truly is. For a long time, this idea lived mostly in the realm of perception and philosophy. It could be dismissed as an interesting but untestable thought. The situation changes when modern physics begins producing results that align with this hypothesis in unsettling ways. When scientists study the subatomic world, they find nothing like everyday experience. Objects stop being objects. They have no clear position. They do not exist steadily over time. They behave as if they are waiting to be observed in order to appear. In these experiments, measurement does not merely record outcomes. It seems to participate in creating them. Before observation, the state of a system is undefined. After observation, it becomes clear. It feels like opening an app on a screen. Before clicking the icon, the content is not there. Once you click, everything appears at once. This is where the interface theory stops feeling abstract. It begins to resonate with how the universe behaves at its deepest level. Reality is not only hidden. In some cases, it does not fully form until an act of observation takes place. Perhaps the icons we see do more than conceal reality. Perhaps they are the only way reality can appear to humans at all. The universe does not present its essence directly. It interacts through a perceptual interface. As this idea settles in, the familiar world begins to feel different. Tables, people, space, and time are still there, still functioning as before. What changes is how we see them. They are no longer absolute foundations. They become windows, symbols, signals. The interface theory does not ask us to reject life. It asks us to be more humble in the face of reality. It reminds us that what we see is only the surface, designed for survival, not for total understanding. Behind the familiar interface may lie a deeper structure, stranger and more alien than anything the human mind was ever built to imagine. As quantum physics begins to speak the same language as this hypothesis, the question is no longer whether it might be true. The question becomes whether we are ready to face a reality that humans were never designed to see. When scientists stepped into quantum mechanics, the sense of unease no longer lived in abstract thoughts or bold hypotheses. It showed up directly inside real experiments, where humans measured the world using the most precise machines ever built. Here, the universe did not behave the way it does in everyday life. It did not sit still waiting to be observed. It seemed to change depending on whether anyone was looking at it at all. In the familiar world, an object always has a definite position. A book resting on a table stays there, whether or not anyone is watching. You leave the room, the book remains exactly where it was. This belief runs so deep that it was never seriously questioned. Yet when scientists began examining the smallest components of nature, that certainty started to wobble. At very small scales, fundamental particles do not behave like a book on a table. Before they are measured, they do not have a clear position. They are not here or there. They exist in a hazy, elusive state, more like a possibility than a solid object. Only when a measurement is performed does their position become definite. This unsettles many people. Measurement is usually thought of as recording something that already exists, not creating it. We assume the world is already there, and measurement simply reveals more about it. Quantum mechanics tells a different story. In this story, measurement seems to play a decisive role. Before measurement, the state is unclear. After measurement, it becomes defined. One of the most famous experiments that exposes this strangeness is the double-slit experiment. In it, scientists fire tiny particles toward a barrier with two narrow slits. Behind the barrier is a screen that records where the particles land. What seems like a simple setup produces astonishing results. When there is no device watching which slit the particle passes through, the pattern on the screen looks like rippling waves. This suggests the particle does not travel along a single path, but spreads out like a wave. But when a detector is added to observe which slit the particle goes through, the wave pattern vanishes. In its place appear traces of individual particles, like tiny marbles flying straight through. The same experiment, the same particles, with the only difference being whether they are observed or not, produces completely different outcomes. This makes one question unavoidable. Do particles decide how to behave on their own, or does observation force them to choose a particular way of existing? The discomfort deepens when we realize there is no way to observe without disturbing. Every measurement is an intervention. The apparatus does not merely look, it interacts. That interaction seems to cause the fuzzy state to collapse into a specific outcome. Reality is not just discovered, it is shaped in the moment of measurement. From here, a chilling question emerges. Before being observed, where is the particle? Does it exist in the ordinary sense at all? Does it have shape, position, properties, or does it exist only as a possibility waiting to be called into being? When this question is extended to the entire universe, the unease multiplies. Before humans existed, before life, before there was anyone to observe, what state was the universe in? Did it exist as clearly as it does now, or was it merely a collection of vague possibilities, gradually coming into focus as observers appeared? Many scientists have tried to preserve the idea of an objective reality that exists independently of humans. They argue that particles do have definite states, we just do not know them yet. Perhaps there are hidden variables, buried deep beneath what we can measure, that determine everything in advance. These variables would be unaffected by observation. Humans simply lack the ability to detect them. This idea feels comforting. It keeps the world stable, keeps reality firmly in place. But when physicists tested this idea with more refined experiments, they ran into a formidable barrier, one called Bell. Bell proposed a simple yet profound test. He showed that if hidden variables truly determine particle states in advance, then experimental results must obey certain limits. These limits can be calculated precisely. They act like rules of the game that all outcomes must follow. When the experiments were carried out, the results broke those limits. Particles displayed strange correlations even when separated by vast distances. When the state of one particle was measured, the other seemed to respond instantly, no matter how far away it was. This happened so quickly that no signal could have traveled between them by any conventional means. These results left only two possibilities. Either information travels faster than anything we know, or particle states do not exist in a definite way until they are measured. Many scientists chose the second option, because it clashes less with what we already know about the universe. Once this possibility is accepted, the concept of objective reality begins to crack. The world is no longer a fixed stage with props waiting quietly for an audience. It resembles a performance that only takes shape when the lights are turned on. Without the lights, the stage dissolves into darkness filled with potential. This does not mean humans create the universe with their thoughts. It means observation plays an essential role in how reality appears. Observation is not just seeing. It is interaction, a connection between the observer and what is being observed. In that moment, a possibility becomes an outcome. The sense of a stable world that exists independently begins to falter. Tables, trees, stars are still there, still following familiar laws. The difference lies deeper down, where the smallest components refuse to obey everyday intuition. The reality we know may be only the stable surface of a very different foundation. Seen this way, quantum mechanics lends weight to the idea of reality as an interface. What we perceive may be only the final result, revealed after countless possibilities have been discarded. The familiar interface hides the chaotic process beneath. We see the outcome, not the process. Reality, in this view, is not a complete picture that exists all at once. It is more like a story written line by line as it is read. Each measurement is a question being asked. The universe answers with a specific result. Before the question, the answer does not yet exist. This thought makes many people uneasy. It takes away the comfort of standing outside, observing an objective world. Instead, humans become part of the story. Our existence, our measurements, our questions seem tightly woven into how the universe reveals itself. Even so, quantum mechanics does not provide a final answer. It simply exposes the strangeness of the foundation beneath our feet. It shows that the most obvious things, position, objects, states, may not exist in the way we assume. They may only appear when summoned by a measurement. As physicists try to hold on to the idea of an independent reality, they are forced to accept growing contradictions. The wall called Bell does not allow an easy return to the old path. Beyond that wall lies a world where observation is no longer a passive act. When reality does not clearly exist before being observed, the concepts of objects, boundaries, separation begin to collapse. The universe is no longer a collection of isolated pieces. It becomes a strangely connected network, where everything is linked in ways that go far beyond everyday experience. Quantum mechanics does not end the story. It opens a door to deeper questions, where humans are forced to reconsider their own place in the universe. No longer standing outside and looking in, we seem to have stepped into the structure of reality itself, becoming an inseparable part of it. When quantum mechanics began to shake the belief that the world exists clearly and fully formed before we observe it, many scientists still tried to hold on to something familiar. They believed that somewhere beneath the strange phenomena, an objective reality still existed. In this view, everything was already decided. Particles were simply hiding their true states, waiting for humans to uncover them. There might be hidden factors, buried deep and unseen, quietly determining every outcome in advance. That idea was comforting. It kept the universe stable and ensured that the world did not depend on whether anyone was looking. Observed or not, reality would still be there, unchanged. Humans were merely latecomers, lifting layer after layer of a curtain to reveal what had always existed. Yet this very desire to preserve certainty led physicists straight into an unbreakable wall. That wall was named Bell. Bell did not propose a new theory of how the world works. He asked a remarkably simple question. If reality exists independently of the observer, if particles already have definite states before we measure them, then experimental results must obey certain limits. These limits act like fences, preventing correlations from becoming too strong. Bell's question sounds abstract, but testing it was very concrete. Scientists prepared pairs of particles that were linked together. They then separated them and sent them to locations far apart. When they measured the state of each particle, they compared the results. According to common sense, each particle should respond independently, based on properties it already carried with it. What they found was completely different. The particles displayed correlations that were almost unbelievable. When one particle was measured, the other responded as if it already knew the outcome, even though the distance between them was vast. These connections exceeded the limits Bell had set for an objective, observer-independent reality. This left two deeply unsettling possibilities. Either information was traveling faster than anything we had ever known, which contradicts the most basic understanding of the universe, or the particles did not have definite states until they were measured. In other words, reality was not predetermined. As experiments were repeated again and again, with ever-increasing precision, the results never changed. Bell's limits were consistently violated. The idea of hidden variables quietly controlling the world from behind the scenes gradually lost its footing. The universe did not follow a fixed script after all. It feels like discovering that a chessboard does not come with its pieces already placed. Each move appears only when someone touches the board. Before that moment, the positions of the pieces were never defined. Reality does not wait in advance. It forms in the moment of interaction. The fracture of objective reality did not stop there. A series of experiments known as delayed choice experiments pushed the problem even further. In these setups, the decision of how to measure a particle is made after the particle has already passed through the apparatus. The choice comes late, seemingly too late to affect what has already happened. And yet, the results suggest that a choice made in the present appears to determine how the particle behaved in the past. Whether the particle traveled like a wave or like a particle depended on a measurement decision made afterward. The past no longer looked fixed. It seemed to be completed only when the measurement occurred. This overturns our familiar sense of time. We assume the past is gone, locked in place and unchangeable. But at nature's deepest level, the past does not seem fully written until an act of observation takes place. Reality depends not only on whether we observe, but on how we observe, and even on when we decide. When all these results are put together, the idea of an objective universe begins to collapse. The world no longer resembles a finished painting hanging on a wall. It looks more like a painting being created stroke by stroke, each time an interaction occurs. There is no one standing outside, watching the whole thing unfold. Everyone is inside the process. This does not mean humans control the universe with their thoughts. It means humans cannot be separated from the universe when trying to understand it. Measurement is not just a passive act of collecting information. It is part of how reality takes shape. The observer is not standing off stage. The observer steps onto the stage from the very beginning. Once reality no longer exists in advance, the idea of separate objects also begins to wobble. We are used to dividing the world into clear pieces. This is a table, that is a chair. This is a person, that is the surrounding environment. Each thing appears as an independent unit with clear boundaries. At the deeper level Bell revealed, that separation is no longer secure. Particles remain linked regardless of distance. The state of one particle cannot be fully described on its own, it only has meaning in relation to the other. Reality starts to resemble an interwoven network, where every part is connected to every other. Our sense of separation, of independent objects, may be a product of human perception. It helps us organize the world so it is easier to understand and use. That does not mean the world itself is truly divided into neat, isolated blocks. At a deeper level, everything may be connected in ways intuition cannot grasp. In everyday life, this difference is hard to notice. A table is still a table, a person is still a person. Familiar reality continues to run smoothly. What Bell revealed does not disrupt daily life. It only disrupts how we understand the foundation beneath that life. From this perspective, the universe is not a collection of objects sitting side by side in space. It is more like a continuous flow of relationships. Objects are simply how we slice that flow into pieces that are easier to name. Those names are useful, but they do not reflect the deeper nature of reality. The collapse of objective reality does not lead to chaos. It leads to humility. Humans can no longer be confident that they see the world exactly as it truly is. We begin to accept that what feels familiar is only the surface, formed from complex relationships beneath. When Bell put an end to the idea of simple hidden variables, he did not explain how the universe works. He only showed that the universe cannot be understood in the old way. Simple answers are no longer enough. Reality demands a new perspective, one where observer, measurement, time, and space all blend together. From there, scientists continue to push forward. Without an objective reality and without independently existing objects, the universe begins to appear as a deep network. Within that network, nothing stands alone. Each part only has meaning through its relationship to others. This leads to a final question. Perhaps the universe was never a collection of separate objects at all. Perhaps it was always a unified whole, divided only within human perception. As that perception changes, our understanding of the universe must change with it. Bell did not destroy reality. He destroyed a false sense of certainty that humans had clung to. Beyond that collapse lies a universe stranger and deeper, where everything is connected in ways far beyond everyday experience. And from that foundation, the story of the universe's true nature continues, carrying us farther from what feels familiar and closer to something we were never prepared to understand. As the idea of an objective reality begins to crumble, something that once felt absolutely certain starts to wobble too, the concept of objects themselves. From childhood onward, we grow up in a world filled with clearly defined things. A table stays put, a wall separates inside from outside, each body seems to have a clean, obvious boundary. Everything is neatly divided, easy to name, easy to use. That familiarity convinces us that the universe is built from separate blocks of matter. But when we look more closely, those boundaries are not as solid as they seem. The human body appears to be a self-contained object, yet every second it exchanges air with its surroundings, absorbs food, releases heat, sweat, and breath. Molecules are constantly flowing in and out. After a short time, very little of the original material remains. The body is not a fixed thing, it is a flow. The table in front of you is not truly still either, even though your eyes insist that it is. Inside it, tiny components are always vibrating, always in motion. We call it solid only because those movements are too small to feel. The sense of firmness arises in the brain, not as an unchanging property of the table itself. What you actually touch is a repulsive force between microscopic structures, which the brain translates into the familiar feeling of solidity. Even the boundary between your body and the surrounding world is not fixed. Skin feels like a wall, but it is constantly receiving temperature, light, and pressure. Every signal passes inward, is processed by the brain, and becomes sensation. There is no absolute line dividing you from the world. At best, there is a dense zone of interaction where inside and outside blend together. Seen this way, objects are no longer independent blocks. They look more like temporarily stable regions within a continuous stream of change. We call them objects because it makes life easier to use, easier to communicate. That way of naming things is incredibly useful, but it hides a deeper truth about the universe. At a deeper level, nothing stands still waiting to be labeled. Everything is always forming, changing, dissolving. Nothing exists forever in the same state. Stars are born, burn brightly, and fade away. Mountains are worn down by time. Oceans are never at rest. Even the most solid-looking things are only temporary arrangements. When we call something an object, we are really freezing a moment within that flow. We choose a short span of time, notice a relative stability, and give it a name. During that span, change happens slowly enough that the brain treats it as constant. That relative stability creates the illusion of an object. It is a very convincing illusion. It allows us to build houses, make tools, plan for the future. Without it, everyday life would fall into chaos. Yet an illusion, no matter how useful, is still an illusion. It does not fully reflect what is actually happening beneath the surface. When objects are seen as processes, the world begins to reshape itself in the human mind. No longer is it a collection of solid things sitting side by side in space. Instead, it becomes a web of interactions, overlapping, intertwining, constantly influencing one another. Nothing exists on its own. Everything depends on relationships. A wave on the surface of the ocean is an easy example. You can point to it, name it, watch it move. But the wave is not an independent object. It is a temporary pattern formed by moving water. When the motion changes, the wave disappears. The water remains, but the form is gone. Objects in the universe may be very much the same. Humans are used to seeing the world as a collection of things because the brain needs stability to function. A world that changes too quickly would be impossible to survive in. For that reason, the brain simplifies. It groups complex processes into clear units. It draws boundaries to make distinctions easier. Those boundaries exist more in perception than in nature itself. As science pushes deeper, this familiar picture begins to fade. At the deepest level, there are no objects in the everyday sense. Instead, there are relationships, repeating patterns, temporary structures. Something is said to exist not because it is a chunk of matter, but because it maintains stable relationships for a period of time. The fundamental nature of the universe may not be matter at all. It could be information, relationships, the ways things influence one another. Matter may simply be how those relationships appear to human perception. We see tables, trees, and people because the brain translates complex interactions into familiar forms. When you look at another person, you see a body, a face, a personality. But at a deeper level, that person is an immensely complex network of biological, chemical, physical, and psychological processes. There is no single point that can be called an absolute center. A human exists through the coordination of countless processes happening at once. This shift in perspective does not make the world feel alien. It simply reveals that the familiar world is a simplified version. That version is good enough for living, loving, and building societies. It is not good enough to fully understand the universe at its deepest level. When objects are no longer the foundation, the idea of ownership begins to blur as well. We say this is my body, that is my possession. Yet everything is constantly exchanging, constantly changing. Nothing truly stays still long enough to be owned completely. We only attach ourselves temporarily to stable structures for a while. This way of seeing softens the boundary between humans and the world. We are no longer standing outside, observing a universe full of things. We are inside a flow, participating in these relationships. The breath you inhale was once part of the outside world. The breath you exhale returns to it. There is no clean cut. When everything is viewed as process, the question of beginnings changes too. Objects do not appear from nothing and then persist forever. They gradually form, are sustained by temporary balance, and eventually dissolve. Existence is a dynamic state, not a fixed condition. This applies even to things we consider extremely stable. A mountain may exist for millions of years, yet it is still being eroded bit by bit. A planet may orbit a star for a long time, but that orbit also shifts. Given enough time, the temporary nature of all structures becomes clear. When we accept that objects are stable illusions, humans begin to look at the world with more humility. We no longer treat what we see as the final truth. We understand that our eyes, ears, and brains are offering a version that is easy to live with, not a complete one. The disappearance of objects as the foundation leads to a major consequence. Space itself, which we have always imagined as a box that holds everything, begins to lose its obvious role. If there are no independent objects standing in space, then the question arises, what exactly is space containing? In everyday experience, space feels like a large room. Objects sit inside it, people move through it. Space seems to exist first, and everything else is placed within it. This view feels natural and intuitive. But it depends entirely on the idea of separate objects. When objects are understood as processes, space no longer looks like a fixed container. It may simply be how the brain organizes relationships to create a sense of distance and position. Space becomes part of our perceptual interface, not necessarily the ultimate foundation of the universe. The distance between two familiar objects may only reflect how strongly they are related. Near or far expresses the potential for interaction, not necessarily a pre-existing physical gap. When relationships change, the sense of distance changes with them. In this view, space is no longer a static stage. It becomes a byproduct of relationships. Where interactions are strong, things feel close. Where interactions are weak, things feel far apart. Space appears as a consequence, not a cause. When objects lose their central role, space no longer feels self-evident either. Both turn out to be products of how humans experience the universe. At a deeper level, there may be no separate objects, and no space as we usually imagine it. There may only be relationships, endlessly changing. This way of thinking does not deny the world we live in. It simply places that world where it belongs, as an accessible surface layer. Beneath that surface lies a deeper structure, where nothing is sharply divided, where boundaries are only temporary. When we understand that the universe is not a collection of objects, we begin to look back at ourselves. We are not isolated blocks standing in the middle of the world. We are part of the flow. Every thought, every action is a process shaped by countless relationships. This perspective does not make humans feel smaller. It makes us more connected to the universe. We are not outsiders looking at a strange world. We are inside it, participating in every subtle motion. The world is not something out there. It is unfolding within every moment we exist. When objects are no longer the foundation, the universe begins to resemble an ongoing story. No chapter stands alone. Each part follows from another, each depends on the rest. And once this is understood, one question naturally remains. If space itself is no longer obvious, what, then, is the deepest foundation of everything? As old ideas dissolved like morning mist, humanity was forced to search for a new way of seeing the universe. That was when a concept that sounded strange at first opened an unexpected door, the holographic principle. It does not tell a story about chunks of matter drifting through space. Instead, it tells a story about how information is arranged, stored, and expressed. It all began with our observations of the deepest dark regions of the cosmos, places where even light cannot escape. These regions do not just swallow matter, they raise a profound question. When something falls in, where does its information go? For a long time, people assumed that the information was crushed and lost forever. That idea felt reasonable, but it created a serious problem. In nature, information does not disappear so easily. Gradually, a different idea took shape. The information is not hidden deep inside those dark regions, it is stored on the surface that surrounds them. Every detail of what falls in is recorded on the outermost boundary. This runs against everyday intuition. We usually think that to know what is inside a room, you have to step inside. Here, all you need to do is read the walls. From this insight, a bold thought began to form. Perhaps everything we see in a three-dimensional space is not truly inside it at all. Perhaps all the information about our world is stored on some surface, much like a three-dimensional image emerging from a thin film. That is where the holographic principle comes in. It suggests that the universe is like a hologram. When you look at it, you see depth, distance, and solid forms. Yet the hologram itself is just a flat surface where information is arranged in a very particular way. The depth you perceive is not inside the image, it exists in the way your brain decodes the information. This comparison makes the idea easier to grasp. A movie projected onto a flat screen can still feel like a vast world. Mountains, cities, and skies appear vivid and alive. The screen does not physically contain those things. It only holds light, arranged in the right patterns. The sense of space arises in the viewer's perception. The universe may work the same way. What we call width, height, and depth could be the result of a projection. A projection that turns a simpler structure into a richly textured world of experience. Because we live inside that projected image, we mistake it for the whole of reality. Seen this way, space loses its role as the ultimate foundation. It is no longer the stage on which everything happens. It becomes more like a moving picture, generated by deeper relationships. The distance between two objects stops being the most basic measure. What matters more is how strongly they are connected. Two things can be very far apart in ordinary space, yet closely linked at a deeper level. Meanwhile, two things that sit side by side may barely affect each other at all. Physical distance becomes a surface feature, not the root cause. At that deeper level, what matters is how information is woven together. These connections do not depend on where things are placed in space. They exist like invisible threads, binding parts of the universe in ways that stretch beyond everyday intuition. Once space is seen as an emergent phenomenon, many long-standing puzzles begin to soften. The idea that two things can influence each other across millions of kilometers no longer feels so strange. They are not truly far apart in the realm of information. They only appear distant in the image we inhabit. The holographic principle does not say that the world we see is fake. It says that the world is the result of a mode of expression. Like an image in a mirror, it is not a physical object, yet it faithfully reflects shape and color. The image is real in experience, even if it does not exist as an independent piece of matter. This shifts how we think about existence itself. Something does not need to occupy space in the traditional sense in order to exist. It only needs information, relationships, and influence. Objects, space, and motion may simply be different ways that information expresses itself. From this perspective, the universe begins to resemble a coded story. What we see is the translation of that story into the language of the senses. Eyes translate light, ears translate vibrations, and the brain assembles them into a world with depth and structure. That world is consistent and stable, enough for us to live our entire lives without noticing the deeper layer beneath it. The holographic principle also blurs the line between inside and outside. We once assumed that the information of a region must lie within that region. Now, it may live on the boundary instead. This strips the idea of a center of its absolute meaning. No place is more special than any other. Every point on the surface matters equally. There is something unsettling about this view. The vast universe suddenly feels more compact in its underlying structure. The complexity we observe may arise from a foundation that is far simpler. Like a long piece of music stored in a few lines of notation. The music comes alive when it is played, not when it sits quietly on the page. The three-dimensional space we know could be the music being played. The deeper structure is the notation. We do not see the symbols directly. We only hear the melody, feel the rhythm, and live inside the sound. Once you grasp this, the question of location changes. Instead of asking where we are in the universe, we begin to ask what we are connected to, and how. Existence is no longer measured by coordinates, but by networks of relationships. The holographic principle also makes the idea of dimensions more flexible. 3 dimensions are no longer a given. They are simply the form that fits human experience. At a deeper level, the structure may be simpler, with fewer dimensions, yet still capable of generating a rich world when projected. It is like a painting that evokes a vast landscape despite lying on a flat canvas. The richness comes from the arrangement, not from the number of physical dimensions. The human brain is remarkably good at creating depth from limited signals. When this way of thinking is applied to the entire universe, we begin to see that what we once called the foundation may be just a surface. What we thought was the surface may be an expression. The boundary between what is fundamental and what is emergent starts to blur. The holographic principle does not offer a complete picture of the universe. It is more like a powerful hint, a direction of thought. It suggests that to understand reality more deeply, we must loosen our grip on familiar intuitions about space, objects, and distance. These may not be the first building blocks of existence after all. If space is only emergent, then the final question becomes clearer. What truly lies at the foundation? Perhaps it is information. Perhaps it is relationships. Perhaps it is something far more abstract than we have ever imagined. There is no clear answer yet. But simply asking the question has already changed how we see the universe. We no longer stand before an empty expanse filled with objects. We stand before a subtle projection, where everything familiar is the image of a deeper process quietly at work. At the end of this line of thought, the universe is no longer a place. It becomes a mode of expression. Reality is no longer a collection of things. It becomes a web of meaning, telling its own story through space, through time, and through the experiences of beings like us. If the idea of the universe as a projection has had time to settle, another question begins to come into focus. What exactly is being projected? Space no longer feels like a solid stage. Objects no longer feel entirely secure. So what lies beneath it all, quietly supporting every familiar human experience? For a very long time, humans assumed reality was made of solid things. Rock, water, trees, bodies. Everything seemed to exist on its own, ready to be touched if you reached out. But as scientists looked more closely, they found those things breaking down into smaller pieces, and then smaller still. Eventually, the question became hard to answer. What is the smallest thing, really? Some thinkers offered an unexpected answer. Maybe the most fundamental layer is not matter at all. It has no shape, no weight. It is information. That idea sounds like philosophy, but it actually emerged from careful attempts to understand the universe through observation. Information here is not text or numbers in the everyday sense. It is difference. It is the answer to a yes or no question, this or that. A switch turned on or off. A single state chosen from many possibilities. Every system, simple or complex, can be described in terms of these differences. Seen this way, familiar objects begin to change roles. They are no longer independent chunks of existence. They become the result of countless tiny answers assembled together. A table is a collection of stable states. A rock is a durable pattern of information maintained over time. This perspective is often summarized in a short phrase. Reality arises from information. Not information recorded from reality, but reality itself built from the smallest units of information. The world is not something that simply exists, waiting to be observed. It appears through the act of observation. That shift completely changes the role of physics. It used to be seen as a discipline that describes a world already out there. Now it looks more like a record of relationships between questions and answers. It does not say what exists in itself. It says that if we ask in this way, we will get that kind of result. An experiment is no longer about uncovering a hidden truth. It is more like a conversation. Humans ask a question through their instruments. The universe replies with an outcome. That outcome becomes the reality that is recorded. Outside of that exchange, there is no complete picture waiting in reserve. This idea makes many people uneasy. It feels like walking into a dark room and only seeing the furniture once the light is switched on. When the light is off, the room cannot be described. We cannot say what it looks like in the darkness. We only know what appears when the light comes on. From this point of view, reality is not a finished film. It is more like a story being told gradually, sentence by sentence, shaped by the questions that are asked. Each observation is a new question. Each result is another line added to the page. Information does not float freely. It is organized by strict rules. Those rules create stability and familiar patterns. Because of them, the world does not dissolve into chaos. A table remains a table. The ground stays beneath our feet. The sky stays above our heads. That stability tricks us into thinking objects exist on their own. In truth, it is because information is maintained in a very robust way. States are tightly linked, producing the feeling of something fixed, bounded, and solid. But when you look closely, those boundaries turn out to be convenient conventions. When information is the foundation, the meaning of existence itself changes. Something exists not because it occupies space, but because it can be distinguished, recognized, and make a difference in observed outcomes. No difference means no information. No information means no experienced reality. This forces us to rethink ourselves as well. Bodies, memories, emotions can all be seen as information structures. Consciousness is no longer a mysterious object hidden inside the head. It looks more like a process, a continuous flow of questions and answers. When you look at a flower, your brain does not touch the external world directly. It receives signals, processes them, and generates an experience. That experience is your reality. It does not describe how the flower exists when unseen. It only tells us how information is organized in that encounter. This view blurs the boundary between observer and world. Both participate in creating the experienced reality. Without an observer, there is no question. Without a question, there is no answer. Without an answer, no picture is drawn. Information does not need to reside in a specific place. It is not like an object stored in a box. It exists in relationships. Change the relationship and the information changes. Ask in a different way and the result changes. Reality shifts with it. That does not mean anything goes. The rules are strict. Not every question produces just any answer. There are limits and frameworks. Those frameworks give the world its consistency. They are like grammar rules in a language. Because of them, the story makes sense. When the universe is viewed as an information system, cause and effect become more subtle. A cause is not just a physical collision. It is a constraint linking answers together. A result today may depend on how a question was posed earlier. This chain gives rise to the feeling of time flowing. Time, in this view, is not a river moving on its own. It is the order in which information is updated. Each moment is a new record, connected to the previous one. That connection allows us to experience past, present, and future. With information as the foundation, many once strange ideas become easier to accept. Reality not being fixed, outcomes depending on observation, the absence of a complete picture before a question is asked. These are natural consequences of a universe built from answers. At the deepest level, reality is not a thing. It is a process. It does not sit still waiting for us to enter. It appears each time we interact. Every living being is a meeting point where information is exchanged, updated, and expressed. This perspective also softens the concept of particles. Particles were once thought of as the smallest bricks of the universe. Now they look more like temporary symbols. They appear when we ask questions in a way that gives them meaning. When the question changes, the symbol changes too. Particles are no longer tiny marbles flying through space. They are how the universe answers certain questions. In a different context, with a different question, the answer may not look like a particle at all. It might look like a wave, a relationship, or a probability. It is like a letter of the alphabet. In one word it carries one meaning, in another it plays a different role. The letter itself has no fixed meaning. Meaning emerges from how it is used in a sentence. Particles are the same. Their meaning exists within a specific observational frame. As the idea of particles fades, the world becomes softer. There are no rigid bricks anymore. Instead, there is a flexible web of information. That web can take on many forms, depending on how we interact with it. This does not make the world less real. If anything, it places human experience at the center. Reality is no longer separated from living. It is tied to asking, observing, experiencing. Every moment of life is a moment in which the universe retells itself. When you look up at the night sky, you are not just seeing distant points of light. You are taking part in an ancient dialogue. Light carries information. Eyes receive it. The brain processes it. Experience appears. In that moment, the universe becomes real in a very specific way. This way of thinking does not answer every question. It opens many new ones. Where does information come from? Where do the rules originate? Why is there something rather than nothing? Those questions remain, quietly waiting. But one thing is clear. When information is treated as fundamental, reality is no longer a cold, lifeless block. It becomes an unfolding story, one in which each of us is both reader and writer. And when that story is examined more deeply, familiar characters like particles, objects, and space begin to dissolve into the background, giving way to a subtler layer of reality, woven from differences, from questions, and from answers. Once information is placed at the foundation, another familiar image begins to wobble, the image of the particle. From a young age, we are taught that the world is built from tiny bricks. Everything is made of minuscule particles, drifting through space, colliding, combining, splitting apart. It is an easy picture to grasp, easy to imagine, like grains of sand forming a beach. And yet, the deeper we look, the more unstable this picture becomes. Scientists gradually noticed something strange. When they tried to isolate a single particle, they never found a tiny marble sitting still. What they observed instead were changes, vibrations, oscillations that appeared and vanished. The particle did not show up as an independent object. It looked more like a fleeting ripple. From this, a different perspective emerged. Maybe particles are not fundamental. Maybe what is fundamental is the field. A field is not a concrete object. It is more like an invisible backdrop, spread everywhere. It is present at every point. There is no true emptiness. Even what we call a vacuum is full of quiet, restless motion. In this view, particles are simply places where the field vibrates more intensely than usual. Like a calm lake, when a drop of water falls, ripples appear. We see the ripples, but no one claims they are separate objects. They are just how the water happens to move at that moment. Particles are the same. A particle is how a field moves at a particular place, for a brief moment. When conditions change, the vibration changes, and the particle disappears. Nothing leaves. Only the state changes. The feeling that something came and went is just how the human brain interprets change. This perspective completely reshapes our picture of the universe. Instead of space filled with particles, we have a continuous fabric. This fabric is not chopped into pieces. It is seamless, stretching everywhere. Everything that appears on it is a temporary pattern. When we look at something familiar, like a chair, we imagine it made of countless hard particles stacked together. In this new view, the chair is a region where fields vibrate in a very stable way. That pattern of vibration is durable and repeatable, so the human brain gives it a name and calls it a chair. Stability tricks our intuition. We are used to things that last, so we assume they exist independently. In reality, they are more like a melody played on repeat. When the music flows steadily, we forget it needs a source. When the source stops, the sound vanishes. Nothing leaves the room. The vibrations simply stop. Look deeper, and even the idea of boundaries starts to blur. We usually think objects have sharp surfaces. In a world of fields, there are no crisp edges. Vibrations gradually grow stronger, then gradually fade. What we call an edge is just where the change becomes noticeable to our senses. This helps explain why isolating a particle from its surroundings is always so difficult. It is not truly separate. It is part of the same fabric. When we disturb one region, the influence spreads to others. There is no absolute isolation. Seeing the universe as a continuous field fabric also changes how we understand motion. Motion used to mean a particle traveling from one point to another. Now it looks more like the spread of change. A pattern of vibration here slowly appears elsewhere. Nothing runs through space. Only states shift. This may sound abstract, but it closely matches everyday experience. When wind sweeps across a field of rice, we see waves rolling across it. No one thinks each wave is an object flying along. It is simply how the wind interacts with the plants, creating a moving pattern. Particles in the universe are like those waves. They are patterns, not things. Patterns can form, change, fade away, then reappear elsewhere with a similar shape. Our sense of continuous existence comes from how the brain stitches moments together into a single story. Once we accept that there are only fields, many things feel less strange. A particle appearing and disappearing is no longer unsettling. It is like a ripple rising and settling. Distant influences become less mysterious. They are not truly distant on a continuous fabric. In this picture, the universe resembles a vibrating ocean. No drop of water exists on its own. Every ripple is shaped by the entire surface. What we call particles are simply how the ocean expresses itself at specific points. This forces us to rethink ourselves as well. The body is also a stable region of vibration. Biological processes are complex patterns sustained by constant exchange with the environment. There is no absolute boundary between inside and outside. There is only gradual transition. Even thoughts can be seen as a form of vibration. The brain does not store thoughts like tiny objects. It generates patterns of activity. One pattern follows another, forming a stream of experience. Thoughts come and go, just like particles appear and disappear. As this view settles in, the world feels softer. There are no rigid, unchanging blocks. Everything is in process. Existence becomes a verb, not a noun. Something exists because it is happening. This perspective also unsettles the special status of space. Space was once seen as a motionless stage, with particles as actors. Now, if particles are just field vibrations, the stage itself is no longer still. Space becomes part of the dance. Fields do not sit inside space in the usual sense. Space may be how we describe the structure of fields. Distance becomes a measure of difference in state. Near and far are not just about location. They are about relationship. When two regions of a field are tightly linked, we call them close. When the connection is weak, we call them far. Physical distance becomes a surface expression of deeper relationships. Space is no longer a container. It is a map of connections. This helps explain why some phenomena seem to defy ordinary distance. They are not crossing space. They are unfolding on a continuous fabric, where near and far differ from everyday intuition. We only see the outcome through the spatial picture our brains construct. As particles dissolve, time begins to wobble too. We once imagined particles existing moment by moment along a steady timeline. In a world of fields, time looks more like the order of change. It is not a river flowing outside reality. It is how we arrange successive states. A vibration changes with a rhythm. That rhythm creates the sense of time. Many intertwined vibrations produce the complex flow we call past, present, and future. There is no external cosmic clock ticking away. There are processes maintaining their own order. Seen this way, even the question of beginnings shifts. Instead of asking where the universe began, we ask which patterns became stable first. Instead of searching for an absolute moment, we look for the emergence of order. This does not make the world vague. It makes it more alive. Nothing is frozen in place. Everything is unfolding. The certainty we feel comes from repetition, not from permanence. When we accept that there are only fields, we can feel closer to the universe. We are not lonely particles drifting in emptiness. We are subtle ripples on the same fabric, vibrating together, influencing one another, participating in a vast movement. This view also brings humility. There is no special center. No ultimate brick. Everything is an expression of the same underlying ground. Differences lie only in patterns, in modes of vibration, in relationships. When we look up at the night sky, instead of imagining particles flying through cold emptiness, we can picture an invisible ocean gently trembling. Stars are regions of persistent vibration. Light is how vibrations spread. Our eyes are simply places where vibrations turn into experience. Our sense of reality becomes more refined. The world does not vanish. It deepens. What we touch, see, and hear still matters. These are interfaces to deeper processes constantly at work. When particles no longer exist as tiny marbles, the special status of space and time fades as well. They stop being absolute foundations. They become ways the field fabric organizes itself to be more accessible to human experience. Behind that familiar interface, a softer reality quietly moves, endlessly vibrating, endlessly telling its own story. As images of particles dissolved into vague vibrations, another pillar of human intuition began to wobble: space and time. From the moment we become aware of the world, we grow used to the idea that we stand somewhere, at a specific moment. Every event needs a place to happen and time to pass. Space feels like a vast room, time like a steady river, carrying everything from the past into the future. But when scientists looked deeper, down to the smallest scales imaginable, that picture began to fall apart. At very small scales, where familiar rules can no longer hold their shape, the idea of location becomes blurry. There is no longer a fixed point you can point to and say, this is the exact place. Distance also loses its familiar meaning. Near and far are no longer as clear as they are on a map. It is like looking at a huge painting from far away. You see the scene clearly: houses, roads, the sky. But when you move too close, all that remains are messy patches of color. You can no longer tell where the roof is or where the road goes. Familiar space only appears when you step back far enough. At that deeper level, the universe does not resemble an empty room. It looks more like a complex web of relationships. What we call a location is not a fixed coordinate, but a pattern of connections. Something is said to be somewhere because it relates to other things in a particular way. From this perspective, space is not something that already exists for objects to sit inside. It is more like a map drawn from relationships. When relationships change, the map changes. Space emerges as a result, not a cause. This reshapes how we understand distance. Two things are not close because they sit next to each other in space. They sit next to each other because they are strongly connected. Nearness is a measure of connection. Farness is a measure of separation. Physical distance is just how that shows up in everyday experience. Seen this way, many once puzzling phenomena become easier to accept. The fact that events can influence each other across thousands of miles no longer feels so mysterious. They are not truly far apart in the network of relationships. They only appear far apart in the spatial picture built by the brain. Space, then, is no longer a silent stage. It is more like a flexible net that stretches and shifts with the relationships inside it. When those relationships change, the net deforms. We experience that deformation as forces, as motion, as curvature. Time undergoes a similar fate. From childhood, we grow used to thinking of time as something that flows steadily, independent of us. Whether we sleep or stay awake, whether we are happy or sad, time keeps moving. Clocks tick. Days follow days. This feeling runs so deep that it is hard to imagine any alternative. Yet at a deeper level, time does not appear as an independent stream. There is no cosmic clock hanging somewhere, counting seconds. Instead, there is change. There is a progression from one state to another. Time emerges from the order of those changes. When a system moves from disorder toward order, we sense a direction. That direction is called past to future. It is not the direction of a river, but the direction of arrangement. In human experience, things tend to move from less organized to more organized in a very particular way. In everyday life, this is easy to see. A tidy room can become messy very quickly. Turning a messy room back into a tidy one takes effort. We feel time moving in the direction where things grow worn and tangled. That is not because time forces it, but because of how states are arranged. From this viewpoint, time does not flow. It is built from differences between states. When nothing changes, no time is felt. A perfectly frozen moment would have no before or after. Time only appears when there is a sequence of changes. This helps explain why memory matters so much. We remember the past because earlier states leave traces behind. Those traces let us arrange experiences into an order. Without traces, without memory, time loses its shape. In the deeper world, where everything becomes fragmented, space and time are no longer continuous backgrounds. They appear as convenient concepts that help humans tell the story of change. At very small scales, these concepts stop working smoothly. There are no perfectly smooth lines, no evenly flowing moments. There are only discrete states, connections switching on and off. Like individual frames making up a movie. When played quickly, we see smooth motion. When we pause on each frame, the motion disappears. Familiar space and time may be like that motion in the film. They are the result of stitching together countless tiny states. At the level of experience, everything feels continuous. At the fundamental level, things may be discrete. Thinking this way, the universe begins to resemble a system modern humans know well, an information processing system. In a computer, every smooth image is built from pixels. Every motion is built from tiny jumps. The user never sees those jumps. They only see the final result. The universe may be similar. What we call continuous space may be built from extremely small units of relationship. What we call the flow of time may be built from steps of information update. Each individual step carries no sense of time. The sequence of steps creates the feeling of flow. This view does not reduce the value of everyday experience. We still live in space and feel time passing. It simply suggests that these are not the deepest layers of reality. They are interfaces. They help humans interact efficiently with something deeper. Like icons on a computer screen. Folders, files, trash bins feel familiar. They do not exist that way inside the machine. Inside, there are only on and off states, abstract relationships. The interface lets us work without understanding the details underneath. Space and time may be such interfaces. They allow beings like us to exist, to move, to remember. Beneath that interface lies a different structure, unlike anything we experience directly. Seen this way, the question of where the universe is becomes meaningless. The universe is not located anywhere. It is the totality of relationships. A better question is how the universe is organized. How relationships are arranged to produce familiar experience. Time, too, is no longer something that carries us along. It becomes a measure of change. When change is slow, time feels slow. When change is fast, time feels fast. That feeling comes from how the brain processes information, not from an external stream. This explains why, in special moments, time seems to shrink or stretch. When the mind is focused, more information is processed and experience becomes dense. When we are bored, fewer changes are registered and time drags on. The clock runs the same, but the experience does not. When space and time lose their fundamental status, the universe becomes more flexible in imagination. It is no longer locked into a rigid frame. It looks like a process that continuously organizes and updates itself. Each moment is a new configuration of relationships. This view also softens our fear of endings. When time is not a river, there is no fixed final shore. There is change and transformation. One order dissolves, another appears. Reality does not stop. It changes form. When we look up at the sky, instead of imagining ourselves as a tiny point in vast space, we can think of ourselves as a node in a vast network. That network has no center and no edge. Each node matters in its own way. Space is how the network is felt. Time is how the network is told. Both serve the experience of beings like us. Behind that experience lies a deeper structure, where familiar concepts no longer hold power. When everything becomes discrete at the fundamental level, the universe starts to resemble a gigantic information processing system. Each state is like a small computation. Each relationship is like a rule. The outcome of countless computations appears as the world we live in. This idea leads naturally to the next step. When space and time are no longer fundamental, when reality is built from discrete steps, the universe begins to resemble a computer. Not a machine sitting on a desk, but a self-running computational process, where everything familiar is just the interface of silent calculations beneath. When space and time lose their role as the underlying stage, the picture of the universe starts to feel strange, yet familiar in a different way. It no longer looks like a vast room filled with objects. It begins to resemble a process unfolding step by step, much like the way an information system operates. Each moment is no longer a point along a flowing timeline, but a state that gets updated. In everyday life, humans are already used to systems like this. A phone, a computer, a video game. The screen shows smooth images, continuous sound, fluid motion. Yet underneath, everything happens in discrete steps. Sometimes on, sometimes off. Sometimes saved, sometimes erased. The user never sees those steps. They only see the final result. The universe may work in a similar way. What we experience as continuous could be built from extremely small pieces of change. At the deepest level, there is no smooth motion. Only a sequence of states. When those states are stitched together fast enough, a seamless experience appears. This idea does not come from pure imagination. It emerges from very serious observations. When humans look at the most extreme places in the universe, where familiar concepts are pushed to their limits, they notice something important. Space does not seem able to store infinite information. There is a limit. Beyond that limit, our usual descriptions collapse. That limit is like the storage capacity of a device. A computer cannot hold infinite data. It has a fixed amount of memory. When it is full, you cannot write more without deleting something else. The universe appears to have a similar kind of limit. A region of space can only contain a certain amount of information, no more. This shakes the idea of absolute continuity. Something truly continuous could hold infinite detail. But reality does not seem to allow that. There is a smallest scale. Below it, questions about detail stop making sense. Like zooming in on a digital image. At some point, all you see are squares. Those squares are not a flaw. They are how the system works. They tell us the image is built from discrete elements. The universe might be the same. Not an infinitely detailed painting, but a colossal digital image, where each pixel is a unit of information. Seen this way, every event in the universe looks like a calculation. One state leads to the next according to very specific rules. No arbitrary jumps. No magic. Just rules applied again and again. A calculation does not need an observer to exist. It runs as long as there are rules. The universe may be the same. It does not need a machine sitting outside to run it. It is the process itself. The internal relationships create the motion. This is very different from the idea of a universe controlled from the outside. No hand pressing a start button. No one sitting in front of a screen. Just a self-sustaining system that updates itself and continues on its own. In a computational system, the most important thing is not the image on the screen, but the rules. Rules determine which state follows which. If the rules are simple enough and consistent enough, the system can produce extremely complex behavior. A simple game with just a few basic rules can generate millions of different situations. A board with identical pieces can produce countless matches. The richness does not come from the material. It comes from how it operates. The universe may also be built from very simple rules. These rules repeat endlessly, everywhere. From that repetition, a rich world emerges. Stars, planets, living beings, thoughts may all be the result of a very long computation. From this perspective, the laws of nature are no longer passive descriptions. They look more like code. They say that when the state is like this, the outcome will be like that. No one needs to command them. No one needs to supervise. The rules apply themselves. This also explains why the universe is so consistent. An experiment done here gives the same result as one done elsewhere. Not because someone guarantees it, but because the same rules are applied everywhere. A computational system can also produce surprises. Even with simple rules, the outcome can be hard to predict. A small change in the input can lead to a large difference in the output. This makes the world both stable and unpredictable. Human life reflects this. The basic rules of biology are fairly simple. Yet from them emerge countless forms, behaviors, and stories. A small change in circumstances can lead to a completely different life. When the universe is seen as a computational system, the idea of randomness changes meaning. Randomness does not mean a lack of rules. It can be the result of a process too complex to predict. Like a long game where every move follows the rules, yet the final outcome is still uncertain. This softens the sense of chaos. The world is not a pile of meaningless events. It has structure. That structure just runs deeper than everyday intuition. We do not see the computational steps. We only see the display. A computational system also has limits. It cannot process infinity in a single step. This matches the fact that the universe has very clear limits. Information cannot travel faster than a certain speed. Infinite detail cannot be packed into a tiny region. These limits are not flaws. They are signs of how the system is built. A program has limits in speed and memory. Because of those limits, it runs reliably instead of collapsing under overload. The universe is the same. Limits allow it to exist in a consistent way. Without limits, everything could become vague and undefined. Limitation is what gives form and creates order. When we accept that the universe is a computational process, humans are no longer outsiders looking in. We are part of the calculation. The body is a complex information structure. The brain is a sophisticated processor. Thoughts are the result of countless updates. This does not make humans insignificant. It puts us in the right place. We are not separate from the universe. We are an expression of the same process. When we think, the universe is computing through us. A natural question follows. What is this system computing? Does it have a goal? The answer may not match how humans think about goals. A program does not need a purpose in the human sense. It only needs rules. Purpose and meaning emerge from the results, not from an original intention. The universe may not be heading toward a specific destination. It is simply running. From that operation, structures appear. Life appears. Meaning gets assigned. All values arise from within the process, not from something pre-programmed. This view makes the question of a controller unnecessary. No one needs to press a button. No one needs to write the code from outside. The rules may be the very nature of the system. They are not chosen. They simply are. This does not answer everything. It only pushes the questions deeper. Where do the rules come from? Why these rules and not others? Those questions remain open. But seeing the universe as a computational system helps us ask new kinds of questions. Instead of asking what the universe is made of, we ask how it operates. Instead of searching for the smallest object, we look for the simplest rule. Instead of seeking a central location, we look for the underlying structure. In everyday life, we can feel this in very familiar ways. A habit repeated each day shapes a personality. A small decision repeated many times creates a path. A life is not built from rare dramatic events. It is built from small repeated steps. The universe may be built the same way. Not from isolated grand moments, but from countless quiet computational steps. Those steps have no emotion. No intention. Yet from them, emotion appears. Intention appears. Stories appear. When we look up at the night sky, we are not just seeing distant light. We are seeing the result of a computation that has been running for billions of years. Each star is a stable state. Each motion is a chain of updates. The entire picture is the outcome of rules repeated tirelessly. This perspective does not strip the universe of beauty. It deepens it. Beauty is not only in the image, but in the structure. Not only in the result, but in the process. When the universe is viewed as a computational system, the final question becomes clearer. What are the laws, really? Are they equations written on paper, or simple rules being executed over and over again? This question opens a new door, one where humans do not just observe the universe, but try to read the deepest code quietly running all of reality. As the picture of the universe as a system of rules slowly comes into focus, something once considered fundamental begins to wobble. Gravity. In our familiar way of thinking, gravity feels like an invisible string pulling things toward one another. Earth holds the moon, the sun holds the planets, objects fall to the ground because a force is acting on them. This explanation is intuitive and matches everyday experience, but it may only skim the surface of the story. At a deeper level, gravity may not need to exist as a separate force at all. It could simply be the result of how information is arranged in the universe. Not an unseen hand pulling everything together, but a structure that causes natural motion to follow certain paths. To grasp this, we have to change a habit of thought. Instead of imagining space as an empty stage where objects are placed and then interact, we begin to see space as something that emerges from the relationships between parts of the universe. Space is not pre-existing. It is woven. Each part of the universe does not exist in isolation. They are linked through information. These connections run so deep that a change in one place can be reflected elsewhere, even across what seems like vast distance. When enough of these interconnections overlap, a familiar structure appears. We call that structure space. In this view, distance is not something given from the start. Distance is how we perceive the strength of connection. 2 points seem close because their link is strong. 2 points seem far apart because their connection is weaker. Space is simply a map of these relationships. When information is unevenly distributed, this structure becomes distorted. Where information is densely concentrated, connections grow thick and tangled. From the outside, we see paths bending toward those regions. We call this effect gravity. No pulling force is required. No mysterious agent is needed. Motion simply follows the structure that is already there. Like a marble rolling across a stretched fabric that dips in the middle, not because someone pulls the marble, but because the surface guides it that way. What is especially striking is that, in this new picture, the fabric of space is not something that existed beforehand. It is created at the same time as the connections themselves. The marble is not rolling on a pre-existing surface. It is part of the very fabric being woven. Here, an important idea emerges: the deep connections between parts of the universe. They are not like physical strings. They resemble informational bonds. When two parts are strongly linked, the state of one cannot be separated from the other. They behave as a single system, even if they appear separate from the outside. When countless such bonds overlap, a geometry appears. This geometry is not drawn with rulers or compasses. It forms from the web of relationships. Curvature, distance, depth are all ways we interpret that network. Seen this way, space is not the original backdrop. It is an emergent phenomenon. Like waves on the surface of water. Waves have shape and motion, but they do not exist apart from the water. Space has geometry and curvature, but it does not exist apart from relationships. Gravity follows the same logic. It is not a separate ingredient. It is the shape of the network. When the network changes, we experience that change through motion. When the network is stable, we call the resulting paths orbits. This helps explain why gravity affects everything in the same way. Regardless of material, color, or internal structure. Not because gravity is fair, but because the network structure does not care about fine details. It only reflects how information is distributed. A stone falls to the ground not because it is pulled. It falls because the natural path in the network structure leads downward. A satellite orbits a planet not because it is being held tight, but because it moves along a curve already built into the structure of space. Viewed like this, gravity becomes the language of geometry. Not geometry drawn in advance, but geometry that arises from connection. We do not need to add a new force. We only need to understand how the network is woven. This perspective also sheds light on the strange relationship between regions that are very far apart. In everyday life, distance is a barrier. In this picture, distance is only a perception. Two points may be far apart geometrically, yet very close in terms of connection. When that happens, a change in one place can be reflected almost instantly in the other. Space is not torn. It is simply connected in ways that defy intuition. These connections do not allow information to be sent freely, but they form the deep structure of reality. When connections change, geometry changes with them. When geometry changes, motion changes. We group all of these effects under a familiar name, gravity. What stands out is that this view requires no central controller. There is no point issuing commands to the entire network. Each connection follows only local rules. And yet, from this simple obedience, large-scale order emerges. Like a flock of birds forming patterns in the sky. No bird is in charge. Each responds only to its neighbors. The flock moves as one. Space works the same way. Gravity works the same way. No commander, only connection. When we look at the universe this way, the pieces begin to fit together. Particles are no longer independent objects. They are excitations of fields. Fields do not exist within space. Space emerges from fields. Fields are linked by information. Information gives rise to geometry. Geometry gives rise to what we call force. Concepts once thought fundamental become consequences. Space is a consequence. Time is a consequence. Gravity is a consequence. What remains at the deepest level is the structure of connections and the rules governing them. At first, this picture can feel unsettling. Familiar foundations slip away. But soon, a sense of continuity appears. There are fewer loose fragments. Everything connects into a single story. The universe does not need many basic ingredients. It needs a way for parts to relate. From that, the familiar world emerges like the surface of a deep ocean. We live at the surface, seeing waves and currents. Below, unseen connections quietly shape everything. When gravity is understood as an emergent phenomenon, it stops being a standalone mystery. It becomes a sign that space is not an empty stage. It is a tapestry being woven continuously, one connection at a time. Every star, every planet, every atom is a node in that network. No node is truly isolated. Everything participates in the shared structure. When one node changes, the network adjusts. We experience that adjustment as force. This view also changes how we think about our place as humans. We do not stand inside space like temporary guests. We are part of the structure that creates space. Every thought, every action is a state within that informational network. When humans measure, observe, and record, the network is reflecting itself. We are not just observing the universe. The universe is observing itself through us. As the pieces fall into place, an unavoidable feeling arises. Reality may not be as deep as we once imagined, nor is it shallow. It is simple at its foundation, yet endlessly rich in its outcomes. Space, time, and gravity are not the starting point. They are the story that emerges when the network grows large enough to see itself. And when that realization settles in, we are left with a final conclusion. Perhaps the universe is not built from rigid bricks, but from relationships. Reality is not a thing, but a process. A process unfolding, self-consistent, self-shaping, and quietly telling its own story. When all the familiar layers are slowly peeled away, a quiet truth comes into view. Space is no longer solid ground. Time is no longer a river flowing at a steady pace. Matter is no longer a set of sturdy bricks holding the world together. What we once believed were foundations turn out to be little more than a surface. At a deeper level, the universe does not begin with objects. It does not start with a point, a line, or a first moment. What appears first may be relationships, abstract connections, repeating patterns, ways information loops back on itself. From that network, everything familiar gradually emerges, like an image rising on the surface of a lake when the wind finally dies down. The world around us, then, is like a painting that is constantly being redrawn. There are no fixed outlines. No permanent ink. Each moment is the painting adjusting itself, retelling its own story. We stand inside that painting, believing it exists independently, solid and stable, outside of us. But it may be that the way we look is already shaping what we see. What we call the universe might not be a thing that simply exists on its own. It may be more like an interface. An interface does not reveal the deeper nature of reality, it presents information in the most usable way. On a phone screen, we see icons, colors, motion. Beneath that are electrical currents, signals, rules the naked eye never touches. The universe we experience may work the same way. The color of the sky, the hardness of the ground, the distance between stars are all ways consciousness interprets data. Not as a trick, but as an optimization. A good interface does not need to show the full truth, it only needs to be clear enough for us to act, survive, and connect. Seen this way, the question, what is the universe, starts to feel less important. Every definition relies on concepts that no longer have firm ground. In their place, another question quietly appears, deeper and harder to avoid. Who is using this interface? Or what? Consciousness no longer stands outside the story. It is not a passive viewer. It is more like the cursor on a screen, the point through which all interaction passes. Without the cursor, the interface still exists in potential, but there is no experience. No images, no motion, no meaning. Perhaps the universe never existed in the way we imagined. Not as a vast container of space filled with matter. It exists as a process being experienced. When experience happens, the universe appears. When there is no experience, the idea of a universe becomes empty. This does not make the world meaningless. If anything, it makes every moment more precious. Reality is not something fixed, it is an ongoing dialogue between deep structure and the consciousness touching it. Every act of seeing, hearing, and feeling is a moment when the world is rendered. People often fear when foundations collapse. But here, the collapse opens a new space for reflection. No longer trapped in the idea of a cold, indifferent universe, we begin to see ourselves at the very center of the story, not because we are special, but because we cannot be separated from it. Consciousness does not need to create the universe in a mythical sense. It only needs to be the condition that allows the universe to appear as experience. Like light, which does not create objects but allows them to be seen. When the light goes out, the objects do not vanish, but their image does. At the deepest level, there may be only abstract rules, formless relationships. When touched by consciousness, they put on the clothing of space, time, and matter. That clothing is so familiar that we mistake it for the essence. So the final question is not about finding a smaller particle, another dimension, or a final equation. The question is already present in everyday experience. What is it that is looking at this world? What is it that hears sound, senses depth, and thinks about itself? Perhaps the universe does not need to exist as an independent entity. It only needs to be observed to become real. And in the moment we ask that question, the universe appears once again, not as an object out there, but as a mirror reflecting the one who is looking into it.